Hello friends, welcome to this video. So here we'll discuss about the second law of motion. In the earlier video, we learned about the first law of motion. Here we'll learn about the second law of motion. So in the first law of motion, to recall quickly, I will give the link somewhere in this video. So first law of motion was all about absence of force, okay? Absence of force, which gives zero acceleration, okay? A body would continue with a state of rest or uniform motion, okay? In the absence of an external force. But in the second law, we are talking about force and acceleration, okay? So in the second law, we'll see that if a force is applied on an object, so the object will get an acceleration, and thereby we will find out a relationship between force and acceleration. Okay, and we will also learn about momentum. So let us see the points, and I will explain the points. If a force produces a small acceleration in a body, okay, you have applied a force on a body and the force was able to produce an acceleration in the body, and another force produces greater acceleration in the same body. The second force is greater than the first one. So what is basically going on? So two forces are there. Suppose one is force F1 and another is force F2, okay? So suppose force F1 produces an acceleration of A1 in that body, and the force F2 produces an acceleration of A2 in that body, okay? Both the forces F1 and F2 are acting on the same body, okay? Suppose A2 is greater than A1, okay? That means the force, the acceleration which is produced in the second body is greater than the acceleration which is produced in the first body. In that case, what will happen? The second force is greater than the first one. That means the force F2 will be greater than the force F1, okay? So this is the thing. That means greater is the force acting on a body, greater will be the acceleration which will be produced by that force on that body, okay? The magnitude of the net force acting on a body is proportional to the product of its mass and acceleration. Both the force and acceleration have the same direction, okay? So force depends on, what is the force? Force depends on two things, mass and acceleration of the body. So basically force is proportional to the mass of a body, and force is also proportional to the acceleration of a body. Combining both these relations, so we can write F equal to kma, okay? K is a constant of proportionality. Or if we consider that K is equal to 1, constant of proportionality is equal to 1, then force is equal to mass multiplied by acceleration. Therefore, the force which acts on a body depends on two things, mass and acceleration, and numerically force is equal to the products of mass and acceleration, okay? So acceleration means we are talking about a definite direction. So force will also be in the same direction as acceleration, okay? Suppose a body is accelerating from left to right, so the force acting on the body will also be acting from left to right, okay? So I hope you have understood the force and acceleration concept here. That means an object will be accelerated. Okay, let me write. An object will be accelerated upon application of a force. Okay, a force is applied, and then upon application of a force, okay, a body can be accelerated only if a force is applied. Without the application of a force, the body will not be accelerated, okay? So that was the statement of the first law of motion. So no force, no acceleration. But here, what we are learning in the first law, If there is a force, there will be an acceleration, or there will be an acceleration only if there is a force. Okay, without force, there cannot be any acceleration. I hope you have understood this concept. So then again, one important topic comes here into picture, which is called momentum. So what is momentum? Basically, it is defined as the amount of motion in a body that a body possesses. Okay, amount of motion that a body possesses, that is the definition of momentum. Mathematically, momentum is given by this formula P equal to mv. Okay, P is momentum, m is equal to m is the mass of the object, v is the velocity of the object. Therefore, momentum P is equal to mass multiplied by velocity. So again, direction of momentum is same as the direction of velocity. Okay, so momentum and velocity, basically they will be along the same direction. Now let us come to understand momentum. Let me give you an example. Okay, car and a truck. Okay, a car and truck are moving with the same velocity. Okay, in a given direction. Suppose the truck will have greater momentum than the car because the truck is heavier than the car. Okay, suppose we have a truck. Okay, we have a truck, big one, and the small one, it is a car. Okay, truck and a car. Consider that both are moving with the same speed or velocity of v. So momentum of which one would be greater? The truck. Okay, the truck, if its mass is capital M, the car has a mass of small m. So capital MV will be greater than small mv. Okay, so momentum of the truck, amount of motion of the truck would be greater than the amount of motion of the car if both are moving with the same velocity. So here one thing, suppose the mass of the truck is capital M. Okay, let me go numerically. Suppose the mass of the truck is maybe 2000 kilometers, 2000 kg, kg. Mass of the car is maybe 1000 kg. Now, suppose the truck is moving with a speed of maybe 50 kilometers per hour. That is the speed of the truck, and maybe the car is moving with a speed of 100 kilometers per hour. Now, can you determine in which object would have greater momentum in this case? So in this case, calculate the momentum. If you calculate the momentum is nothing but mass multiplied by velocity. Okay, so we will get the same number. Okay, the number would be 1 multiplied by 10 to the power 5. 1 multiplied by 10 to the power 5 kg kilometer per hour. So here it will also be 1 multiplied by 10 to the power 5 kg kilometer per hour. Okay, so the momentum in each case is equal. Okay, so why equal? So when we talk that a heavier object will have heavier momentum, because here although the mass of the car is mass of the truck is heavier than the car, but here the truck has got a velocity which is half that of the car. Okay, the car has a velocity of 100, the truck has a velocity of 50. Therefore, the momentum of both the truck and the car will be equal. Okay, so but if both are moving with the same velocity, suppose now the truck raises its speed to 100 kilometer per hour velocity, then of course the truck will have got higher momentum. Okay, similarly, an example is discussed here. A bullet is fired from a gun on a sandbag. Okay, bullet you have fired from a gun on a sandbag. So what will happen? The bullet will make a hole on the sandbag. Okay, but if you throw a stone on the same sandbag, will it be able to make a hole in the sandbag? The answer is no. Why the bullet will make a hole in the sandbag? The bullet will make a hole because it has greater momentum. Okay, the a bullet travels at a speed of maybe, I don't know, 300 kilometer per second, and whereas a stone maybe, I don't know, 30 kilometers, 30 sorry, 300 meters per second, 300 meter per second speed of a bullet, and the stone maybe 30 meter per second. Okay, so you see the bullet has got a much higher velocity than the stone. Okay, so the bullet will be able to make a hole, but the stone not, because the bullet will have greater momentum than the stone. Okay, so if so I hope you have understood now how important it is to understand the concept of motion. Similarly, suppose you are standing and one of your friends come and push you. Okay, and maybe the next time another friend who is maybe heavier but running with the same speed comes and pushes you, so you will be displaced more with when the second friend pushes you, because the second friend is heavier and therefore his momentum would be higher. Okay, I hope you have understood the concept of momentum here. So okay, so Newton's second law in terms of momentum. So, is there a way we can express Newton's second law of motion in terms of momentum? Yes. So, Newton's second law can be defined in terms of momentum. How? The net force acting on an object is proportional to the rate of change of momentum. Okay. The net force which is acting on an object is proportional to the rate of change of momentum. That means how much momentum is changing with time. Okay, the net force acting on an object is proportional to the rate of change of momentum. Okay, so let us understand it. Suppose momentum. What is momentum? Momentum P is equal to m multiplied by v. Okay. So change of momentum. Okay, so change of momentum. Suppose initially the object is moving with a velocity of v1. Suppose the object has got a mass of m. So what will be its initial momentum? Its initial momentum would be mv1. Now later maybe you have applied a force on the object and its velocity increases to v2. So what will be the momentum of the object? That would be mv2. So what is the calculated change in momentum here? The calculated change in momentum is mv2 minus mv1. Okay. So what is the rate of change of momentum? Rate of change in momentum, that would be, so whenever we are talking about a rate, so we are always talking about the change with respect to time. Okay, time. Okay, so m multiplied by v2 minus v1 by t. That is what we get. But now remember, what is the definition of acceleration A? Acceleration A is the velocity change in a given amount of time. Okay, yeah, in a given interval of time. So how much velocity of an object changes in a given interval of time? So that is how we measure acceleration. So this term, this simply represents the acceleration of the body. So mass multiplied by acceleration. Okay. So what is acceleration? Its definition has been discussed in another video whose link I will give here somewhere. So acceleration is equal to v2 minus vy by delta t. I mean the change of velocity with respect to time. So that can be substituted here, and we can see that the rate of change of momentum is equal to mass multiplied by acceleration, and mass multiplied by acceleration is nothing but force. Okay. Therefore, force is nothing but rate of change in momentum. Rate of change in momentum, that is the force. Okay. So I hope you have understood how force and momentum are linked. Okay, so force is equal to the rate of change of momentum. Okay, to find the momentum change with respect to time, that would give us the force. So this is another application. This is how Newton's second law of motion is related to momentum. Okay, so now let us come to the SI unit of force. The SI unit of force is Newton. Okay, Newton. So how would you define Newton? So F is equal to ma. Okay. So that means a force is said to be 1 Newton if the force acts on an object of mass 1 kg and produces an acceleration of 1 meter per second square. So if m equal to 1 kg and a equal to 1 meter per second square, therefore F would be 1 Newton. Suppose mass is 1 kg, acceleration is 1 meter per second square, then what would be the force? 1 multiplied by 1 kg meter per second square, that would simply give us 1 Newton. Okay. So the force acting on an object is said to be 1 Newton if it acts on the object and produces an acceleration of 1 meter per second square, provided the object has a mass of 1 kg. Okay. So I hope you have understood the definition of Newton, or 1 Newton force. Okay. If the force acting on the body is 0, its acceleration on the body will also be 0 as well, since mass cannot be 0. Okay, that means in the absence of force, there is no acceleration. So force F equal to ma, we have learned. If force acting on the body is 0, so acceleration will also be 0. Why? Because the mass of the body cannot be 0. Since the body has got some fixed mass, so if force equal to 0, then only acceleration will be 0. So isn't that the first law of motion? First law of motion says the same thing. So an object will like continue with the rest of its state of rest or uniform motion if it is not acted upon by any external force. And this is the first law of motion. Okay. So yes, so I hope you have understood the definition of 1 Newton of force, then the relationship between force, mass, and acceleration, and that acceleration will be 0 when force is equal to 0. So we have discussed here the concepts of second law of motion, okay, how a force gives an acceleration to a body. We have learned about momentum, okay, momentum means the amount of motion in a body. Then Newton's second law and momentum, how it is related, and what is the unit of force, SI unit of force, and how is it, and how to define 1 Newton of force. So these things we have learned in this video. So if you have any questions or comments, please type in the comment section. Thank you very much for watching, and see you in the next video.